Now that we have completed the journey of wireless evolution from GSM to LTE, in this module we shall focus on deployment aspects. There are several paths of evolution from 2G technologies to LTE. Wireless network operator has to choose the best path to LTE. In this module we shall focus our attention mainly on how LTE may be deployed by different types of operators. After completing this section, you will be able to summarize the evolution path for LTE. Step through LTE deployment with GSM, GPRS, Edge. Explain LTE deployment with GSM to UMTS, R99, HSDPA, HSUPA, to LTE. LTE offers peak data rates of 300 Mbps in downlink, and 75 Mbps in uplink. The path of evolution begins from the GSM voice network. GSM evolved into the GPRS as packet data network, with the peak theoretical data rate of 171 kbps, but the practical capacity of 70 kbps. GPRS shares the access network with GSM, but has a separate packet-based core network. With some coding and modulation enhancements, GPRS becomes Edge, with the 3 times increase in peak data rate capacity. LTE can evolve directly from GPRS or Edge networks, without the need to go through the UMTS network. Alternatively, GPRS and Edge network can evolve into UMTS network, and follow the evolution path for LTE. UMTS Release 99 was the first release of UMTS. It is characterized by change in access technology from TDMA to CDMA. UMTS Release 99 has a theoretical data rate of 2 Mbps, but the practical capacity is 384 kbps. UMTS Release 4 doesn't impact the data, but through the introduction of Bearer Independent Call Control, BICC, UMTS R4 provides a more efficient core network. Significant improvement in data rates are introduced in UMTS Release 5 and Release 6. In addition to introduction of IP Multimedia Subsystem, IMS, supporting all IP networking, UMTS R5 introduces high-speed downlink packet access, HSDPA, which increases peak downlink data rate to about 14 Mbps. UMTS R6 introduces both Multimedia Broadcast Multicast Services, MBMS, capable of supporting services such as mobile TV services, and high-speed uplink packet access, HSUPA, which increases the peak uplink data rate to about 5.76 Mbps. UMTS Release 7, also known as HSPA+, introduces multiple input multiple output, MIMO, systems. MIMO is a system that uses multiple antenna, concurrently sending and receiving parallel data streams, which further improve efficiency of the system. UMTS R7 offers peak data rates of 42 Mbps downlink, and 22 Mbps uplink. LTE can evolve directly from either UMTS Release 5, Release 6 or Release 7. Here is an evolution scenario, where a network operator evolves his network from GSM GPRS Edge to LTE. Let's assume that the operator is a large operator covering both rural and urban areas. When the demand for new services such as high-speed packet is seen, it is typically the urban areas that need to be addressed first. the operator will start deploying LTE in the urban areas first. In a large network, this will result in LTE coverage appearing as islands in the middle of the largest GSM coverage area. The size and location of LTE coverage areas will be driven by market demand. In the rural areas, which do not have a demand for high data rate services, the operator can hand down LTE users to the GSM GPRS Edge network. Now, we look at an evolution scenario, where a network operator follows the 3GPP standard evolutionary path, and grows the network from GSM GPRS Edge to UMTS HSPA to LTE. The operator provides wireless voice and data service coverage to the entire service area with the GSM GPRS Edge network. In the areas where there is moderate demand for data services, the network operator may overlay UMTS HPSA over GSM GPRS Edge network to support optimized data services. Typically, urban areas are the first ones with the need for new services, such as high-speed data services. While the operator may not have deployed UMTS HSPA services as a complete overlay to the GSM-based network, every increasing demand in urban areas may be met by deploying small islands of LTE in appropriate areas. The size and location of smaller LTE coverage areas will be driven by market demand. In areas which do not have a demand for high data rate services, the operator can hand down user to UMTS HSPA and/or the GSM GPRS Edge network as dictated by the deployed network. Figure shows the GERN and UTRAN interworking architecture. Let us now discuss the deployment example of LTE with GERN and UTRAN. 3GPP Rule 7 specifies the feature called 3G Direct Tunnel, where the user plane goes direct between RNC and GGSN. 3GPP Rule 8 specifies an SAE-GW and an MME. SW upgrade of the GGSN gives the SAE-GW functionality, and the MME functionality, in the SGSN. LTE-capable eNode B are introduced. This completes the module. Click Next Topic from navigation menu.